that our whole universe is living on a membrane inside a much larger, higher dimensional space. It's almost as if we were living inside a loaf of bread. Our universe might be like a slice of bread, just one slice in a much larger loaf that physicists sometimes call the bulk. And if these ideas are right, the bulk may have other slices, other universes that are right next to ours, in effect, parallel universes. Not only would our universe be nothing special, but we could have a lot of neighbors. Some of them could resemble our universe. They might have matter and planets and, who knows, maybe even beings of a sort. Others could certainly be a lot stranger. They might be ruled by completely different laws of physics. Now, all of these other universes would exist within the extra dimensions of M-theory, dimensions that are all around us. Some even say they might be right next to us, less than a millimeter away. But if that's true, why can't I see them or touch them?
If you have a brain living in a higher dimensional space and your particles, your atoms, cannot get off the brain, it's like trying to reach out, but you can't touch anything. It might as well be on the other end of the universe.
And it's a very powerful idea, because if it's right, it means that our whole picture of the universe is clouded by the fact that we're trapped on just a tiny slice of the higher dimensional universe.
It is a powerful idea, especially because it may help solve one of the great mysteries of modern science. It has to do with gravity. It's been more than 300 years since Isaac Newton came up with the universal law of gravity, inspired, as the story goes, by seeing an apple fall from a tree. Today it seems obvious that gravity is a powerful force.
It would seem to most people that gravity is a very important force. It's very strong. It's very hard to get up in the morning, stand up, and when things fall, they break because gravity is strong. The fact of the matter is that it's not strong. It's really a very weak force.
Gravity pulls us down to the Earth and keeps our Earth in orbit around the sun. But in fact, we overcome the force of gravity all the time. It's not that hard. Even with the gravity of the entire Earth pulling this apple downward, the muscles in my arm can easily overcome it. And it's not just our muscles that put gravity to shame. Magnets can do it too, no sweat. Magnets carry a different force, the electromagnetic force. That's the same force behind light and electricity. It turns out that electromagnetism is much, much stronger than gravity. Gravity, in comparison, is amazingly weak. How weak? The electromagnetic force is some 1,000 billion, 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 billion times stronger. That's a 1 with 39 zeros following it. The weakness of gravity has confounded scientists for decades. But now, with the radical world of string theory, filled with membranes and extra dimensions, there's a whole new way to look at the problem.
One way of approaching the question of why gravity is so weak compared to all the other forces is to turn the question completely on its head and say, no, actually, gravity isn't very weak compared to all the other forces. It just appears to be weak.
It may be that gravity is actually just as strong as electromagnetism, but for some reason, we can't feel its strength.
Consider a pool table, a very large pool table. Think of the surface of the pool table as representing our three-dimensional universe, although it is just two-dimensional. and think of the billiard balls as representing atoms and other particles that the universe is made out of.
So here's the wild idea. The atoms and particles that make up stuff in the world around us will stay on our particular membrane, our slice of the universe, just as the billiard balls will stay on the surface of the pool table. Unless you're a really bad pool player. But whenever the balls collide, there is something that always seeps off the table. Sound waves. That's why I can hear the collision. Now, the idea is that gravity might be like the sound waves. It might not be confined to our membrane. It might be able to seep off our part of the universe. Or, think about it another way. Instead of pool tables, let's go back to bread. Imagine that our universe is like this slice of toast, and that you and me and all of matter, light itself, everything we see is like jelly. Now, jelly can move freely on the surface of the toast, but otherwise it's stuck. It can't leave the surface itself. But what if gravity were different? What if gravity were more like cinnamon and sugar? Now, this stuff isn't sticky at all, so it easily slides right off the surface. But why would gravity be so different from everything else that we know of in the universe? Well, it turns out that string theory, or M theory, provides an answer. It all has to do with shape. For years, we concentrated on strings that were closed loops, like rubber bands. But after M theory, we turned our attention to other kinds. Now we think that everything we see around us, like matter and light, is made of open-ended strings. And the ends of each string are tied down to our three-dimensional membrane. But closed loops of string do exist. And one kind is responsible for gravity. It's called a graviton. With closed loops, there are no loose ends to tie down, so gravitons are free to escape into the other dimensions, diluting the strength of gravity and making it seem weaker than the other forces of nature. This suggests an intriguing possibility. If we do live on a membrane, and there are parallel universes on other membranes near us, we may never see them, but perhaps we could one day feel them through gravity.
If there happens to be intelligent life on one of the membranes, then this intelligent life might be very close to us. So theoretically, and purely theoretically, we might be able to communicate with this intelligent life by exchanging strong gravity wave sources.
So, who knows? Maybe someday we'll develop the technology and use gravity waves to actually communicate with other worlds. Yeah, hey, it's Brian. How you doing?
Brian. Jerry Jabba Simpsons.
We don't really know if parallel universes could have a real impact on us. But there is one very controversial idea which said they've already played a major role. In fact, it gives them credit for our existence.